Hello students, welcome to physics class. Today we discuss the term free fall and acceleration due to gravity. In the last session, we learned universal law of gravitation. From that, we learned that every object in the universe attract each other with a force which is directly proportional to product of their masses and inversely proportional to square of distance between them. We also learned that Earth is also attracting every object towards its center. That's why we know that if you have thrown a stone in upward direction with a certain velocity, after reaching a particular height, a maximum height, its velocity comes to zero. Thereafter, because of the attraction or because of the gravitational force of Earth, it falls towards the Earth. Then we can say that object is falling towards the Earth. The only force acting on the object is the gravitational force. No other external force is acting on the object. The force acting on the object is gravitational force. Then we can call that object is in free fall. We can say that object is in free fall. So the free fall is nothing but the any object. Whenever an object fall towards the earth under the attraction of gravitational force of earth, it is said to be free fall. No other force is acting on an object other than the gravitational force, then we can say that that object is in free fall. So that is a free fall. Whenever an object fall towards the earth under the attraction of gravitational force of earth, it is said to be in free fall. For example, if you are dropping a particular object from a particular height above the earth's surface, it is in free fall. Or if you are thrown a ball in upward direction, it will reach a maximum height. After that, its velocity comes to zero. Then, because of the attraction of the earth, it falls towards the earth. Then it is a free fall. So, free fall is nothing but the falling under gravity. Gravitational force is the only force acting that object. So, that is free fall. Now, when an object is in free fall, we know that a force is acting on the object. So, whenever a force is acting on an object, its velocity will change. Or otherwise, we can say it is accelerated. Its speed increases because it's a pull in the direction of velocity. Once a force is acting in the direction of velocity, it gets accelerated or its speed is increases. But the direction of speed is not changing because the force is acting in the direction of speed or in the direction of velocity. So the magnitude of velocity is only increasing, but there is no change of direction of velocity. It is falling vertically towards the center of the earth. So an acceleration is involved in this case. As force is acting in the direction of velocity, an acceleration involved in this free fall. And that acceleration is known as acceleration due to gravity. The definition: the acceleration produced in a freely falling body under the gravitational pull of the earth is called acceleration due to gravity. Usually it is denoted by a symbol g, small letter g. Acceleration due to gravity is denoted by a symbol g, and it is measured in meter per second square. So acceleration due to gravity is the acceleration of a freely falling body. As the force is acting in the direction of velocity, the velocity of the freely falling body is increases. So we can say there is an acceleration, and that acceleration is known as acceleration due to gravity. And for Earth, the acceleration due to gravity is denoted by a symbol g, and it is measured in meter per second square. Now let us find an expression for acceleration due to gravity. So see the situation. Suppose we have an object of mass m at a height h above the earth's surface. Here we have a mass m h above the earth's surface. Small letter h above the earth's surface. So this is earth, and a small mass, say m, is placed at a height h above the earth's surface. So r is the radius of the earth and capital M is the mass of the earth. We know that once the object is placed or dropped from here, it falls towards the earth because of the gravitational force of attraction. It falls towards the earth. Once it falls towards the earth, it experiences an acceleration. There is an acceleration because of the attraction of the earth. So that acceleration we call as acceleration due to gravity. So we can write by second law of Newton, the force acting on the object is equal to mass into acceleration due to gravity, or mass into acceleration. Here acceleration due to gravity. So we are writing that force acting on the object is equal to m into g. M is its mass and g is the acceleration. From second law of Newton, we learned that the force is equal to mass into acceleration. Here acceleration is known as acceleration due to gravity. That's why we're writing m into g. That's equal to the attraction between the earth and this mass. The gravitational force of attraction between the earth and this mass. We know that it is equal to g into product of their masses. Say m is the mass of earth and small letter m is the mass of this object. So g into m divided by distance between these two bodies. Here this is the center of the earth and this is the mass. So the distance between these two masses, that earth and this mass, can be considered as r plus h. R plus h. What is r? Radius of the earth. And what is h? The height above the earth's surface. So we are taking that d equal to r plus h. D equal to r plus h. That is, d is nothing but distance between the center of the earth and the center of this mass. D is the distance between the center of the earth and center of the mass. D is equal to radius of the earth plus the height above the earth's surface. So that's why we are writing as d square. Distance between the two objects is d. D equal to r plus s. So mg is equal to m divided by d square. And if you want to find an expression for g is equal to, one of the m can be cancelled from the both side. G is equal to g capital M by d square. Okay, this is the expression for acceleration due to gravity. G is equal to g capital M by d square. G is the universal gravitational constant. Capital M is the mass of earth. D is the distance between the center of the earth and center of the mass. Suppose if the object is very close to the surface of the earth, that is, h is very small comparing to the radius of the earth. If h is very small, that is, the object is very close to the surface of the earth, we can neglect this value of h and we can write d is approximately equal to radius of the earth. Instead of d, we can write the radius of the earth, because when comparing to the radius of the earth, the height above the earth's surface is very small and negligible. So that's why we are writing d is equal to r. If the object is very close to the surface of the earth, we are writing d equal to r. So now the expression we are rewriting like this way: g is equal to capital G m by r square. What is r? Radius of the earth. M, mass of the earth. G is universal gravitational constant. So acceleration due to gravity is equal to G is equal to G m by r square. So what are the factors which decide the acceleration due to gravity? We can say that is mass of the earth. G is a constant. Mass of the earth is also constant. But the radius of the earth, you know that the earth shape is not a perfect sphere. Because of the particular shape of the earth, it have a different radius at the equatorial region and the polar region. So the gravitational acceleration due to gravity is not a constant at everywhere on the surface of the earth. It is varying according to the place. So we can say that the acceleration due to gravity at the pole is greater than the acceleration due to gravity at equator. This is the equatorial region and this is the polar region. So we can say acceleration due to gravity at the polar region is greater than the acceleration due to gravity at the equatorial region because of the particular shape of the earth. Okay, so G is not a constant, but in certain case, once you are doing the numerical question and all, for convenience, we will take the acceleration due to gravity as a constant. Now let us calculate what is the numerical value of acceleration due to gravity. For that, we are substituting all this value. We know that what is capital G. Universal gravitational constant is equal to 6.7 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2. That is G. And mass of the earth is approximately m is equal to 6 into 10 raised to 24 kilogram. It's an approximate value. M is equal to 6 into 10 raised to 24 kilogram. And the radius of the earth is equal to 6.4 into 10 raised to 6 meter. Substitute all this value for G, acceleration due to gravity. G is equal to 6.7 into 10 raised to minus 11. Instead of G, we substitute this value 6.7 into 10 raised to minus 11. Now capital M, mass of earth, 6 into 10 raised to 24 divided by square of radius, 6.4 into 10 raised to 6 whole square. So if you are doing this calculation, we will get approximately 9.8 meter per second square. The acceleration due to gravity is equal to 9.8 meter per second square. That's the value of acceleration due to gravity. Okay, it means that once an object is falling under the attraction of the earth or under the gravity, at every 1 second, after every 1 second, its speed is increases by 9.8 meter per second. It means its acceleration is 9.8 meter per second square. It means its velocity increases each and every time, each and every second by 9.8 meter per second. Once it moves in the upward direction, its speed is decreases by 9.8 meter per second in every second. Once it falling down towards the earth, its speed is increases at every second. So that's why we saying that once an object is thrown upward, it have a negative acceleration, retardation, because once it trying to move in the upward direction, it have a opposing force, the attractive force of the earth. That's why it's a retarding motion. That's why once it move in the upward direction, its velocity decreases continuously, and finally its velocity comes to 0. After that, it falling towards the earth. So once the object is moving upward direction, it have a negative acceleration. So we can take the G is equal to minus 9.8 meter per second square. When the object is moved in the upward direction, opposite direction of gravitational force, acceleration is negative, retardation. But once it's falling down towards the earth, its speed is increases. So we can say it have a positive acceleration. So by the time we will take as G is equal to plus 9.8 meter per second square. That's all about gravitation force and free fall and acceleration due to gravity. That's all today. Thank you.